So zinc
Hi
is
everybody
a
and
substance that
welcome to
oxidizes
this
always a reactive metal
second
product, so always on the
video
left side.
in
Now,
solutions
bromine was
chapter.
reduced. Notice that the oxidation state decreased or was
Here
reduced from 0
we'll
to
be
0.
discussing
So
about
Br2 was reduced.
the units of
A substance that
expression
is oxidized
for
is known as a reducing agent,
concentration
and a substance that is reduced is an
in
oxidizing agent.
solutions. So
Zinc is
there
a
are
reducing agent because it
basically
caused the other
7
substance,
units
bromine,
of
to be reduced.
expressions.
Bromine is the oxidizing agent because it caused the other substance, zinc, to be oxidized. Metals, most metals, particularly the active ones, are usually good reducing agents because they like to give away electrons. Non-metals like bromine are oxidizing agents because they like to take away electrons.
It's
Whenever a substance gives away or loses electrons, it is oxidized. A substance that receives or gains electrons is said to be reduced.
for
Now let's say
concentration.
if we were to mix calcium oxide and water. Calcium oxide is a basic anhydride. Metal
The
oxides
first
are considered basic
is
anhydrides
of
because when
course
you add them to
your
water, they turn into a base.
mass percentage.
Calcium oxide reacts with water to produce calcium hydroxide. Whenever you see a metal with an OH, it's a base. Basis produces hydroxide ions in solution. So notice that this is a combination reaction. It's in the
This
form
is
A
your
plus B turns to AB. Now this is a
W by
combination reaction
W.
which is already balanced. Is it a redox
So
reaction or
this
is it not?
is
Notice that there's no pure elements in this reaction. We have a compound, compound, compound. If you don't see a pure element, it's safe to say this is not a redox reaction. So there's
mass
no
of the
transfer of electrons in
component
this
in the
reaction.
solution.
Now let's say if we were to have calcium carbonate, and if you add heat to it. Metal carbonates, they decompose when you add heat. This is going to turn to calcium oxide, and it's going to release a volatile component that is contained in calcium carbonate. That volatile component is carbon dioxide gas. Whenever you add
Divided
heat,
by
if a gas
total.
can escape, it will escape. Now what kind of reaction do we have here? So we have the reverse of a combination reaction. We have a larger product breaking down into two small components. So this is known as decomposition. Now is it redox or is it not a redox reaction? Notice that we have a compound, compound, compound. No pure elements. So it's not a redox reaction.
So this is
Now
your
say if we have magnesium nitride,
mass percentage.
which is a solid.
Second is your
If we add heat to it,
volume percentage.
typically whenever you add heat to a compound, if it's enough, if it's like a lot of heat, it can decompose. If there's a gas that can be produced, then the formation of the gas is going to drive the reaction to the right, making it spontaneous. When you heat magnesium nitride, it's going to turn into magnesium metal and nitrogen gas. Nitrogen gas is very stable, so heat is going to drive the reaction to the right, producing this volatile gas. To balance it, we simply need to put a 3 in front of Mg. So is this a redox reaction or is it not? So we know this is a decomposition reaction. We have a compound breaking into its elements. And it turns out it is a redox reaction.
Volume of the
We have a compound,
component
and
in
we have a pure
solution.
element, so it's a redox reaction. Now there are some other common decomposition reactions that you should know. The decomposition of
Divided by
potassium
total
chloride, if you
volume
add heat,
of
this breaks
solution.
down into potassium chloride and oxygen. Another one is mercury oxide, which is a solid. If you add heat, it's going to turn into mercury metal, which is a liquid, and you're going to get oxygen gas. So notice that heat
Into
favors the
100.
formation
So
of
this
gas.
will give you
If the gas
your
is being formed, it's going
volume
to drive the reaction to the
percentage.
right, making it spontaneous.
Third, mass
So
by
both of
volume
these are decomposition
percentage.
reactions. Now are they redox reactions? If you look at the first one, we have a compound, and here we have a pure element. So it's a redox reaction. For the second one, compound, pure element, redox. To balance the first one, notice that we have 3 oxygens on the left, 2 on the right. The least common multiple of 2 and 3 is 6. So to make them equal, we need to get 6 oxygen atoms on both sides. So we need to put a 2 in front of KCl3 and a 3 in front of O2.
So
we
this
have
is
6
your
oxygen
mass
atoms on
of
both sides.
solute.
Notice that we have 2 potassium atoms, so we have to put a 2 in front of KCl. Now it's balanced. For mercury oxide, all we have to do is put a 2 and a 2, and it's balanced. So we have 2 mercury atoms and 2
Dissolved
oxygen
in
atoms. Now we said that whenever you have a metal oxide with water,
100
it's
ml
going
of
to produce a base.
solution.
So metal oxides are basic anhydrides. Now what about non-metal oxides, like sulfur dioxide? Non-metal oxides are acid anhydrides because when you put them in water, they will turn into an acid. SO2 plus water turns into H2SO4.
Fourth one,
If you
parts
put
per
sulfur dioxide in
million,
water,
ppm.
it's going to turn into sulfuric acid. If you mix carbon dioxide with water, it turns into carbonic acid.
So your ppm is
So as you can see, non-metal oxides
number of
are
parts of
acid
the
anhydrides.
component.
Metal oxides are basic anhydrides. Now let's say if you have calcium hydroxide. If you add heat, you're going to get the reverse reaction of what we had in the last example. This is going to break down to calcium oxide and water.
Number of
Now depending on the temperature, water can escape as a liquid. Or if
parts
it's hot
of
enough, it can
that
become steam.
particular component. Okay.
Now let's say if you have a single
So
replacement reaction.
here when I
Zinc
mean
plus,
component,
actually let's change it.
so it
Let's
can
make it
you
aluminum
can either
plus nitric
calculate
acid.
for solute or for solvent.
What are
Okay.
the products of the single
So
replacement reaction?
essentially mostly it
Aluminum
is
is
given
going
in
to
terms
displace
of
hydrogen out of
solute.
the
So
solution, and it's going to pair up with C.
just note that component is
Aluminum is
what
going
you
to lose 2
want to
electrons, turning
calculate.
into the aluminum plus
So
3 ion.
that's how it is
And chloride usually has a minus 1 charge.
understood.
So using the crisscross method,
So number
these
of
two
parts of
together,
the
they turn
component
into
divided by
CO4.
total number of.
Now when hydrogen is displaced out of the solution, it's going to be elemental hydrogen, which is diatomic and it's going to leave us gas. Aluminum is a solid.
Parts of
HCl is aqueous, which means that this
all
is
the
solid.
components.
Aluminum chloride will also be in aqueous phase. So in this reaction, we're placing a solid chunk of aluminum in a solution of HCl, which means the HCl is mixed with water. So whenever you see
Solution.
AQ, that means that it's dissolved in water. Now,
Into
this single replacement reaction
10 to
is
the
a
power
redox reaction.
6.
It turns out that all
So
single
parts
replacement reactions
per
are redox reactions.
million.
Notice that we have a pure element
Your
and a compound,
next
so it's a redox reaction. Now, which substance is oxidized and which one is reduced? So aluminum is in the 0 oxidation state because it's a pure element, but in its compound it's +3. Now hydrogen is in the +1 oxidation state because
next
chlorine
is
is
your
-1.
mole fraction.
Whenever hydrogen is bonded to a nonmetal, it usually has a +1 charge, but when it's
Very
bonded to a metal,
important.
it usually has a -1 oxidation state or charge.
So it is
Now elemental
if we have two
hydrogen is 0.
components
So aluminum goes from 0
A
to 3.
and B,
So the
the
oxidation
mole
state goes
fraction
up. So
XA
aluminum was
is
oxidized.
given by
Now
number of
hydrogen
moles
and
of A
HCl,
divided
they
by
went down.
number of
Water
moles
was
of
reduced
A
from 1 to
plus
0.
number of moles
So
of B,
HCl
total number of
was
moles.
reduced. Since
Okay.
aluminum was oxidized,
Sixth
aluminum is also known as a
concentration
reducing
term.
agent. Hydrogen was reduced, so
Now use
it's
your
called the oxidizing agent. So as we can see here, most active metals are reducing agents, and non-metals are usually oxidizing agents. Going back to this reaction, A quick way to distinguish a single replacement reaction from, let's say, a
Is
double
your
replacement reaction
molarity?
is this method. In a single replacement reaction, typically you have an element reacting with a compound. When you see that, it's usually a single replacement reaction. By the way, how would you balance this reaction? What would you do to balance it? So notice that we have 3 chlorine atoms. So we're probably going to put a 3 in front of HCl. And notice that we have an odd number of hydrogens and an even number over here. The least common multiple between 3 and 2 is 6. So that
Is
tells us that
moles
we
of
need 6 hydrogen
solute?
atoms. So let's put a 3 here to make it 6, and let's put a 6 there. And let's rebalance it. So now that we have 6 hydrogen atoms on both sides, let's balance the chlorine atoms. We have
Get
6
the
atoms of
volume
chlorine,
of
so we need to put a 2 in front of AlCl3. And so since we have 2 aluminum atoms on the right side,
solution
2 in front of Al, now the reaction is balanced. Now
in
consider this reaction.
liters.
Let's say if we have an aqueous solution of silver nitrate plus magnesium chloride, and we want to find out what the product
And
of this reaction.
lastly,
Nitrates are always
the
soluble, so this is going to be aqueous. To know this, you need to understand
molality,
the solubility rules. Nitrates, acetates,
which is
ammonium,
given
which is
by
NH4+, are
moles
always
of
soluble.
solute.
Alkali metals like lithium, sodium, potassium, rubidium, they're always soluble. The halides like chloride, bromide, iodide are generally soluble except with silver, lead, and mercury. So with magnesium, chloride is soluble. Now this is a double replacement reaction.
Divided by
We have a compound
mass
reacting with a
of
compound. In a single replacement reaction, it's an element plus compound.
solvent
In a double replacement reaction, it's
in
two groups on
kg.
the outside are going to pair up together,
So this
and
is
2 in the middle
important.
are going to pair up.
Another important
So Ag
thing,
is
so
vector
this
of
is
CO. So we have
usually
Ag1,
represented
Cl,
by
because
capital
these two
M,
have the same charge, even though the
and
signs are
this is
opposite.
usually
Right from the
represented
information.
by small m.
Now,
So
chloride is
just
soluble
know.
with everything except silver, lead, and mercury. So silver is
And
an exception. So this is
another important
whenever
thing
you mix
is,
two aqueous
as
solutions
you
together,
already
and if
studied
you get a
in your
solid product,
12th class,
this double replacement reaction is also known
molarity
as the
is
precipitation
a function
reaction,
of
just like we have in this example.
temperature. Okay, it
Now we need to
differs
find the
from
other product.
place to place
So
because
let's pair
if the
magnesium
temperature is
reaction.
different,
Magnesium is an alkaline earth
so
element with a neutral charge,
volume
and nitrate is a polyatomic ion with a
molarity
neutral
is
charge.
a
Using the crisscross method, you can see that it's Mg1NO32. Whenever you have multiple polyatomic ions, make sure you enclose the polyatomic ion within the parentheses. Now we said nitrates are
function
always
of
soluble, so
temperature,
magnesium nitrate is
and
going to be aqueous.
therefore it differs from place to
So now what we need
place
to do at this point
because
is
that
balance the
is
reaction.
because your
So we have 2 nitrates on
volume,
one
which
side, so we have to
is
put 2 in front of HCl3.
it's divided by volume of solution in liters, right? So
Now
volume
the
is a
reaction is
function
balanced.
of
Now this particular double replacement
temperature.
reaction, would you
Okay,
consider it
while
a
molality
redox reaction? Or
is not does not
notice
change
that there's
from
no
place
pure
to
element
place
in this
because
compound. Not compound, but
mass
there's no pure element in this reaction.
is
This is a
not
compound
a
that's
function of
compound, compound,
temperature.
So
So
double
that is
replacement reactions are
something.
never redox reactions because you won't see any pure elements in this
With
reaction.
this, we
Now typically with double replacement reactions, you need to be able to write the net ionic
conclude
equation. How
this
can we do
video
that in
to
this particular example?
next video.
The
We'll
first
get
thing that we
into
need to do is write the total ionic equation.
the
So everything that is in the aqueous phase,
mostly I
we need
think
to separate
we
into ions except the solid.
see
So we have 2
either
Ag
liquid in
plus ions
liquid solutions
and 2 nitrate
or
ions
we'll see
in AgNO3.
gas in liquids.
In this compound,
Okay.
MgCl2, we have a magnesium ion and 2